This is a multimeter, and this is also a multimeter. And there are two different kinds of multimeter. There's two different brands, but they do the same thing. The multimeter you have in your kit, it probably looks different, but I'm going to use these two, which are the ones that I have at home, and we're going to go through what a multimeter is, how to use it, and why you need to use it. So in project one, the starting point in your worksheets for project one is figuring out how to use a multimeter. And you've probably used them before, but we're going to go through it in a lot more detail because in project one, to explore electricity, like you have to use the multimeter all the time. So the multimeter is going to become your friend. It's going to save your butt for doing the project one work. So the first thing about a multimeter is they're both off. So if I turn it on, you can see some numbers. And if you turn on your multimeter and you don't see any numbers on that screen, it means that your batteries are dead. And all you have to do at that point is unscrew it with a screwdriver. And you should have, I think you've got screwdrivers in your kits. And they run on a 9-volt battery. So all you have to do is put a new battery in there if you find that your multimeter is dead. So it may have been sitting in your kit over the summer and drained the battery, whatever. So no biggie, not the end of the world. If nothing is happening, it doesn't mean it's broken. Probably just means you need a new battery. So all you'd have to do is pop this out, put a new one in, screw it back together, and you're good to go. These are the probes. These are the things that will measure resistance and voltage and any electrical property that you're going to be working with. Okay? So now to plug the probes into the multimeter, you have to make sure that you're using the right range. Okay? So if you look down here, it says milliamps. And if you look at that middle one, it says COM. And this one is 10 amps. Direct current. Okay. Again, it may be the order of these pins on your multimeter might be different, but you're going to have the same symbols. You're going to have COM, which means ground, and remember that ground is always black, and it's a negative charge in the circuit. So COM is going to be black, and then we're going to use the smaller voltage always because for all the projects we do in class, like the most voltage we would ever be using is pretty much 12, maybe 20 at the most. For project one, it's going to be 5 volts, 3 volts, very small voltage, so we need milliamps. So the red one goes there. Okay? And the probes, probes will measure electricity. So this battery's dead because I'm only getting like, hang on. I'm only getting 5 volts out of a 9-volt battery, so it's not really reliable. I wouldn't use it in a project. And anyway, for working on your projects, it's probably better to use some kind of plug-in power source, okay? Because batteries aren't very reliable. Okay, they're not reliable when the voltage is dropping, okay? When it's new and you're getting 9 volts out of it, it's really good, and then when it starts dropping, it won't work very well. Okay, so here are the probes, the properties that we're going to be working with, okay? The first symbol we're going to look at is continuity. On this one, you can see that there's a little symbol there that looks like kind of like a speaker. Okay, it's right there. What that does is it measures whether a material is conductive or not. So with the continuity symbol turned on, it means that any conductive material is going to beep when the probes are put on it. So here are some of the materials that you've got in your kit. Things like conductive thread. You can hear it beeping. So conductive thread is conductive, obviously. Velostat, not conductive. So what's happening with the probes, when you put it to that continuity symbol, it takes a very small amperage, a very small voltage of electricity, and it puts it through. And so that if a piece of material, like conductive fabric, will take that electricity from one probe to the other, it beeps. And it doesn't matter, it's not a power and ground kind of thing here at this point. It's just, there's just a little bit of electricity running between the two. Makes no difference which one you do. Okay, so here's a cool thing you can do, like screwdriver, the metal part of the screwdriver is conductive, the plastic part isn't. Okay, so if you had a plastic handle screwdriver and you were doing some electrical work and you got a shock, you'd be saved. Tape, not conductive. Copper tape. Copper is conductive. It beeps. Here's a little light sensor. Okay, so the electricity is going through the sensor. If it wasn't beeping when I did that, it would be like, oh wait, I think this thing is broken. Okay, whatever. Okay, now here's a very cool thing you can do. So remember that when it's on the continuity symbol, it's sending a little bit of electricity through, and when you put an LED remember that the long post on the LED is positive, so in this case it does have to be positive. This one is negative. It stopped beeping, but the LED lights up. So that's kind of cool because that little bit of electricity going through from the multimeter is enough electricity to light up the LED. So that's like a little fun fact there. Okay, so if you wanted to check your circuit, for example, here's a breadboard that I've made and it's got a circuit going. So for example, if I go on the plus side over here, if I look at the ground side of that and I look at this one, I got a beep. So you use the probes to check your circuit. If you had a problem with this circuit and you wanted to know, gee, is the electricity getting through? Okay. You could do something like put one of the probes on the ground side of the input and then check the different wires. So this one is not grounded, this one is grounded. So that tells me that the electricity is coming through on the ground wire there. Here's the symbol for direct current voltage. You can see it's a V and a solid line and a dotted line. And if you look at the worksheets, we've got all the symbols explained in the PDF worksheets. So multimeter is off, multimeter is on, and on direct current voltage, we've got a range of voltages. It goes from 2 to 20 to 200 to 600. On a different multimeter, you might have different numbers, but the principle is the same. You have to kind of know what range you're measuring with the multimeter. It doesn't automatically give you the correct reading right off. So what that means is measuring up to 2 volts, it'll be accurate. Measuring up to 20 volts will be accurate. 200 volts, 600 volts. So you kind of have to know what you're measuring. So let's have a look at an Arduino. So you guys know from your experience that the Arduino can output 3 volts and it can output 5 volts. So if you have a look at the side of the Arduino, I'm trying to focus here. Yeah, you can see the pins. You've got 2 ground pins, you have a 5 volt pin, and you have a 3.3 volt pin. So one of the problems that I have, and I think everybody has, is that sometimes you get a pin, a piece of wire put into one of the pins in the Arduino, and it breaks. And if you look at the 5 volt, what I did was I put header pins into the side of the 5 volt Arduino, right? So if I pull it out, these are the header pins, and I stuck them in there, and what happens is you can see the one that's really sticking up. It's hitting the pin that's locked in there, but this way I can still work with it. It's still going to be viable, okay? So I'm going to measure the 5 volts coming out of the Arduino, okay? And if we get the probes, we've got our voltage set to 20, and it should be giving us 5 volts. And it isn't. If I put it on the 3.3 volt pin, I'm getting 3.3 volts. If I put it on the 5 volt pin, I'm getting 5 volts. So I had to push it down a bit there. Okay, so that's how we read the voltage. And remember, we looked earlier at the battery here that's kind of half dead. It's only outputting 5 volts, so it's almost half dead. Okay. Now, sometimes it's not really convenient. It's a two-handed thing to use the probes. So sometimes it's a lot easier to take an alligator clip, put it on the probe, and then you can be hands-free. And this is a lot more convenient a lot of the time. And this pin is still giving me a lot of trouble, but I don't have any free Arduinos that don't have any broken pins. So there I'm getting my 5 volts, and let's check the 3.3 volts. So I'm moving the red alligator clip over to the 3.3 volt output on the Arduino, and it's all working really well. So let's have a look at a different example. In this example, what I've got is I've got this thing that's called a barrel jack, and there's another tutorial that'll explain how to use a barrel jack. So you can see that I'm getting positive and negative. So the electricity is being plugged in, and it's coming in from the right. So I've got a 12 volt plug plugged into the outlet on the wall. Comes in here, and if you were doing this on your own, you'd want to know the first thing you want to do. Like, let's say that you plug that into your breadboard. So now you want to know, okay, is it actually working the way it should be? Is it, are you getting 12 volts? And the answer is, remember that we've got the multimeter set reading up to 20 volts, and got the red one on positive and the black one on negative, and yep, there's 20 volts, 11.99. Cool. So, measuring direct current, remember that 99% of the time, you're going to be setting it to 20 volts direct current is probably the range, because that'll give you an accurate reading for the 5 volts you're using from the Arduino. You might be using 3.3 volts, etc. So it's most of the time you're going to be there. So what is this range thing? Why is that accurate to read up to 600 volts, and this is 200 volts, and this one is 20 volts? Let's see what happens. So I wanted to demonstrate the idea of the range of the voltage for direct current. Okay, so I've got, I simplified the setup a bit here. So we have 12 volts coming in from a wall plug, and I put a wire on the breadboard and a red wire that's reading the volts here, and then a black wire that's reading the ground from the rail. So remember that when you're working with a breadboard, when you put power into that red rail running down the breadboard, it means that any of these pins is going to have 5 volts of power, and that any of these pins on the blue rail are going to have a ground. And you can see on the multimeter, we're set to 20, so it's going to be accurate up to 20 volts to read that voltage, okay? So what happens if I go to 200? Well, it still works, but the decimal point changed. So we've got 12.03, and now we've got 11.9. And then if we go to 600, we're getting 11, okay? So the numbers are accurate, but if I go in that direction and I want to measure up to 2 volts, it doesn't work, okay? So you have to be in the ballpark. You have to kind of know what you're doing. It's not really magical where it'll give you accurate readings. You have to do a little bit of math. So if you learn the decimal system in grade 6 or something like that, you should be good. Now, another thing is that it's really, it's very simple when I just have 12 volts coming in and 2 wires, but your circuits are going to get complicated all the time. So what happens if we reverse it and I put the ground plug there and the power plug there? So you'll notice that now we have minus 12 volts, okay? So in reality, there is no minus voltage. It just means that now the black wire is taking the voltage, right? And it indicates that because that minus sign, what it really means is like there's an error. So anytime you're looking at your multimeter and you're going, okay, wait a minute, it's giving me a reading, but my circuit doesn't work. It might be that your ground wire and your voltage wire might have gotten mixed up in your circuit. In fact, circuit building things get very complicated very fast. So this is what you're going to be doing with your multimeter, is going through your circuit and every step of the way, check, are you getting the right voltage coming through? And if you use the multimeter all the time, and as you build your circuit and you check every wire you put in, it's going to be really good. It's going to be foolproof. You're going to get the results very quickly. You're not going to have to rip your whole circuit apart and try and find where the problem is, which is kind of annoying. One more thing about the wall plugs. Here's an outlet, and everybody should know, or maybe you don't know or can't remember from science class, this is alternating current coming out of the wall. But we want direct current going into our circuit. So that wall plug is actually converting AC power to DC. So we're getting 12 volts of direct current electricity coming out of the wall. So keep that in mind. And never, never, ever, ever stick the probes. Never stick this into a wall outlet, because you'll blow something up. Yourself, your cat, your house, something. Bad things happen when you use alternating current because it's very dangerous. Direct current at the voltages that we're using, you can't hurt yourself. You can stick 20 volts through your fingers, nothing. 5 volts, can't even feel it. Okay, so keep that in mind. As long as you're using low voltage direct current, you're not going to hurt yourself. The worst damage you can do is you might run 5 volts through a circuit, through a component that has a maximum of 3.3 volts, and it might cost a lot of money, and you might fry it, so you would be out of pocket, but you're not going to hurt yourself at all. So the ohm symbol on the multimeter is that one, okay? So that means ohms. So here's how we can measure resistance. It's the same principle where we have to figure out the right range. And so you can see that I've got the multimeter is set to 200. So it means up to 200 ohms, you can measure the resistance. Now, the thing about the resistors, like if you just sort of place the probes on there like this, you're probably not going to get an accurate reading. You might, but you might not. So a lot of times you have to just pick it up, put your fingers right on the end of the probe like this, and then see what the reading is. Okay, 98.4. That's a 100 ohm resistor. And resistors have colored bands on them, okay? But the system of measuring the size of the resistor with the colored bands, it's kind of complicated. I've given up on it myself. And so the best way to do it is just use the multimeter. And the other thing that'll help you a lot is keep your resistors in the bag they came in. So this tells me that that's 22K, 22,000 ohms. This one is 10K, 10,000 ohms. We use these a lot with potentiometers and with flex sensors. So that's going to be one you're going to use a lot. 470R, 470 ohms. You could probably even, when you're in doubt, just test it with your multimeter. So 470, it's kind of 40.457, but I'm in the 2K range, so that's accurate. Okay. Another way that you can measure the resistors on a breadboard is as a circuit. So if you put the alligator clips on a wire, and I think there's a 10K ohm resistor in there, let's see what it'll do. Okay, so I had to change the range up to 20K, and it's giving me 9.89. So that is a 10K ohm resistor. That's the one you use with analog sensors. Okay, so measuring resistance, same principle as voltage, where you have to be in the right range. Remember that K means 1,000, so if you pick up a resistor and it says 10K, that means 10,000. And you want to have a corresponding number on your multimeter, right? 20K. So measuring a 10K resistor, set it up to 20K and you'll get an accurate reading.